Hey everybody, how you doing? AmpRepairGuy.com. I have another power supply here that I constructed for a ham radio operator. Purchased the case, had the transformer custom made, installed all the components, wired everything. So the transformer is a EPD. It's actually rated for 28 kVA, 5600 volt AC at 5 amp CCS. Weighs about 330 pounds, 22 inches wide. So this is what the customer wanted. It's tremendous overkill. The guy says he runs legal limit. Whatever, not my business. Just building a power supply, that's it. So I'm going to go over this step by step. Utilizes the same type of soft start as the other power supply video that I made, so I won't go over all of that. I'll just give you a basic rundown. So, well, it does not use a time delay. You know, if there's a fault on the secondary, or if something happened in the primary, anything with, you know, after the contactor that switches the switch side of the transformer, it would pop a little 3 amp glass fuse instead of having to rely on the 125 amp line breaker. Way better than using the time delay setup. So here we have the rectifier board that I made. I ended up taking the board and I high potted it before I replaced the diodes to see what the voltage breakdown rating would be between each string. It was over 20 kV, so I always want to be sure before I do anything. I always check everything. I always want overkill to everything. So, you know, if something happens, you know, something weird, I want it to survive. Dust, hair, whatever. So you have the oil filled capacitor, you have the plate bleeder resistors. I have 400K in here. They dissipate about 40 something each. Just use Ohm's law. I have unloaded, it's like 8040 volts. I have 248 here, so about 8040 or so. Rectified. I verified it with my fluke meter with the high voltage probe. So I have a whole box of these resistors. I'll explain how I mounted them. First off, I used GTO high voltage wire rated for 15 kV. I have the ceramic insert in each resistor. They're mounted to brackets. The brackets are mounted to the phenolic board, which is isolated from ground with Teflon and nylon bolts. I know it's overkill, but I had everything. Why not use it? I have tons and tons of stuff. So, okay, so when you hook up a plate current meter, you need to isolate all the B negatives from ground. The filter cap B negative, the rectifier B negative, and the bleeder B negatives are all connected together, and then they connect to these diodes, these safety diodes rated for 10 amps each. I have 4 in parallel, reverse connected to ground. And then it goes over to the plate current meter, and then the opposite side of the plate current meter is directly grounded since I'm not using a grid current meter. And then it goes to the umbilical cord, which has the B negative and the B positive, which connects to the RF deck. That's made by Alden, rated for over 10 kV DC. So we have the glitch resistors, same mounting method. They won't go anywhere. They're rated for 300 watts each, continuous. Tremendous overkill. But once again, I have a whole box. You know, you don't want your glitch resistor to open. You don't want it to act like a fuse. You know, so you want it to limit the fault current and survive the fault. So I have a whole roll of number 8, so I triple up number 8 per side of the primary. A contactor down there. Switching one side of the primary Each contact's rated for 50 amps. It's overkill. Used all that green wires, Teflon coated, silver plated stranded. Number 2 SOW cord. Got the intake vents. Everything's all zip tied. Got the 12-volt supply, which runs the meter lamps. So there's a fan on the back of this that I'll show you. His blower and his amplifier that he already has at his house runs on 120 up in the RF deck. I guess his supply that runs the relays runs on 120. So I like the load to be balanced in the RF deck. So what I did was I took these 2 transformers, they're rated for almost 4 amps each. I put 2 in parallel. I wanted some overkill, even though it was a little over 4 amps. It was right at like 4 point something that you'd have for a total load on the 120 line coming out of this. I wanted some overkill, so I put 2 in parallel. That takes the 240 and it steps down to 120, so I did not need a neutral wire. So I'll show you the back. I have a 10-inch fan forcing air in. I have about an 1.5 inch gap between the core and the back wall. The fan's pushed against the core, around the transformer, past the parasitic suppressors, and then out the vents on the side. We have the twist lock plug that carries the 240 and the 120 up to the RF deck. You have the fuse holders for everything that runs on 240 in here. These are ground studs. There'll be a wire that goes from this stud up to another stud on his RF deck, both sides, just another safety ground in case he lost the ground, and the Alden connector. A lot of people like the James Millen. I like these Alden connectors. This is the new age type connector. Way better. Rated for way more voltage. The other one works okay. You have to isolate it once you get to a certain voltage, and the material just isn't as strong as this. This is just a better connector. But so that's about it for the inside. Once again, tremendous overkill, but that's what the customer wanted, and he wanted to pay. The board's isolated from ground with the Teflon standoffs. Got the proper meter dropping resistor. It's rated for it's over 10 kV. I forget what it was. I think it was like 14 or more. It's made by Dale. See how long it is. Over it's got about 2 inches between the resistor and that bracket, but remember that's not at ground potential. The B positive connects to that end of the resistor, then you have the B negative over here. So customer wanted some meter lamps, so bought these cool meters that have the indigo or whatever lights. There's the soft start resistor. Once again, no timer. So let's fire this thing up and see what happens. See that? Comes right down. No delay. Probably see the reflection, the light reflection on the panel. Lights don't flicker or anything. It's awesome. Can't beat that. So if there was a problem, this little fuse would pop, plate won't come on. Fan stay on, fan will come on, but plate will not come on. Put the fuse back in. See, I'll show you. It's a little 3 amp fuse. 3 amp. I don't know if you can see that or not, but let me put that back in. Can't beat that, huh? So that's about it. If you like this video, please like it, subscribe if you want. If you have any questions, feel free to ask. You can go to my website, amprepairguy.com. I also grounded the panels together with number 8 Teflon. I'm sorry, number 10 Teflon, silver plated, stranded. I used grade 8 hardware. Oh, another thing, just wanted to point out. Yeah, this cabinet is reinforced with 3/4 inch 6-ply wood. I used carriage bolts, 1/2-inch carriage bolts to hold the transformer in place, and then 7/16 carriage bolts. There's one there and one in each corner. The customer is going to put it on a steel reinforced dolly, so I had to slide this transformer and it was so heavy. But that's about it. So yeah, if you like it, just like, subscribe, check out my website. We have what more videos to come. We do all sorts of stuff. We have all sorts of stuff in for repair. You name it, we can do it. Just boils down to money, and you know, we re-engineer stuff. We don't just fix it and send it out the door. We want to make it right so it doesn't have to come back or go to anyone else. Just keep on working. So thanks for watching. Have a blessed day. Take care.